and welcome to a video on one of the extras for this week. Involves something called maps, which a lot of students often have trouble with, so I decided to create this video to kind of give you some help with this extras so you can learn maps a little bit better and become more comfortable with them. In this particular extras, the idea is to be able to keep track of a list of students based on their course ID. The class they're taking. So the first thing we have is a courses class, and you can see what we do with this courses class is we create a list of students, an array list of students, and that means we need a student class, right? And then we add students to our list by creating new student objects. And then we use this courses class to add a course by giving the course identifier and the list of students. So what this thing is doing is it's keeping track of a list of students based on a course ID. We're going to do this with two courses. Here's CSCI 101 and here's CSCI 121. You can see we do the same thing. We create another list of students, add the student objects to that list, and then add the list to our courses object here, passing it the course ID and the list. Then here at the end of this main, we use a scanner to have the user enter a course, such as CSCI 101. And what it does is it calls the getStudents method of the courses object, passing the course identifier, expecting to get back the list of students, and it then prints them. Now, if the user enters an invalid course ID, then the list that comes back should be an empty list because that course doesn't exist. So here's a printout of the expected output from this program, which you can download here, and it gives you the main, and you can actually download that, and if you get it working, this is what you should see happen. If you enter CSCI 101 as your input, you should get back the list of students taking that class. And it's a list, so it's automatically printed inside square brackets. And these are your student objects. And the only way this is actually going to work is if you override the toString for these students. So that's something that we'll need to do for this extras assignment. If you enter CSCI 122, we get a different list of students, and these are the students that we added here for CSCI 121. Oops, I have 122 here, but it's actually 121. We'll fix that. If you enter a course number that doesn't exist, for example, like this one, you should print an empty list. Okay, so there's your output. Okay, so here are some hints for you to complete this problem. First, you have to create a student class. And again, it should have a toString method that returns the student's name in first-last format. We have to edit the course class. So we're given some of this code. We have to edit so that it uses a hash map that contains instances of the student class to keep track of who is in a course. The key of the hash map, and all of these maps really consist of a key and then a value. For example, you might have a map that keeps track of students or people based on their social security number. So the key would be the social security number, and when you give the hash map that key, it should give you back the person associated with that key. In this case, though, your key is a course ID, and the value is actually a list of students. So when you give it a course ID, you get back a list of students as your value. Okay, so that's what we need to do with the course class. And as we mentioned, an invalid course passed to getStudents of the course should return an empty list if it's an invalid course. All right, let's jump into the solution here. Take a look at the first thing you have to write, which is the student class. And this you should be pretty good at by now. Student class has a first and last name that are private instance variables, which make up its state. We have a constructor here that takes the first and last name, and it sets the instance variables equal to those parameters for that constructor. And then the last thing we need to do is just write a toString method that returns the first-last string representation of this class. And you can see I'm using string format here. My specifiers are %s, %s. The last name goes into the first specifier, the first name goes into the second one, and we return that string from toString. And remember, this is automatically called whenever we try to print or get a string representation of this class. For example, if we print a list of students, an array list of students, each of those students will be printed using this toString function to get the string that should represent the student. Also notice that we have an @override here. This isn't necessary, but if you use it when declaring toString, it will help produce more useful error messages if you make a mistake when developing this method. This can be done for any method that you're actually overriding from some parent, and in this case, student is actually derives from object, and object has a toString method already. So we're actually overriding that to give it its own behavior. All right, now for the interesting class, which is courses. Courses has two methods, getStudents and addCourse. And we saw those in action up here. Here's where we call addCourse, where it takes the course ID and the list of students. And here's where we call getStudents, which takes a course ID and returns that list. So here's where we're setting a value for a key, and here's where we're getting the value based on a key. So we have to write these methods, and the way we're going to accomplish this is with a hash map inside of our courses class. The hash map is going to have a string for its key. The course ID is a string. So when we declare the hash map, this first thing, the key, is a string. And remember, the value, which is this part right here, is going to be an array list of students. So remember, when you're declaring a hash map, the first item here is the key, and the second item is your value. Then we have to create a new instance of this. It's called course map, and the new instance, we just repeat this type, respecifying the key and the value for the hash map. But we use a new, and the constructor will be the default constructor that we're calling. So we're calling a new on the default constructor of the hash map, whose keys are strings and whose values are array lists. Okay, now that we have our hash map declared, we need to use it to keep track of our students by course ID. So I'm going to jump down to this method first, where we're actually adding a course. This method takes a course ID, which is a string, and a list of students. And remember, this actually ends up being the key, and this ends up being the value. So all we have to do is add that course ID, add the students, the list of students based on this course ID. And this is done in a hash map using the put method. The put method takes the key and the value. In this case, course ID is the key, and the student list is the value. Okay, the last method we have to write is the getStudents method, and this one's a little bit tricky. Let's ignore these two lines right here and jump to the easy one. If the user passes a course ID and we want to get the associated list of students for that course ID, the method you call for in a hash map is get. So we take the hash map called course map and we call get on it, passing the course ID, and this will return the list of students that we've associated with it. And remember, this all happened down here in the addCourse method. This is the simple part. The complicated part is what happens if the course ID has not been, if a list of students has not been specified for the course ID that's passed here. Well, if that happens, then you'll get a null value when you call get. So what we need to do is check for this case with an if statement. If the course map's get method, when passed course ID, returns null, it means there is no list of students associated with that course ID. And the specification for this problem says when this happens, we need to return an empty list. So what I do in this situation is if I get null back, I add an empty list of students for that course ID. So anytime you pass a course ID that has not been associated with a list of students, we will then add an empty list for that course ID right here. Then when we call return here and pass that course ID, there will be a list inside the course map, guaranteed. And it will be the empty one that we just added, which will cause this to return an empty list for course IDs that don't exist. This is a very common thing to see when you're using hash maps to keep track of lists. Anytime you have a hash map to keep track of lists, you need to cover the case where the list hasn't been added yet for that key, and add an empty list in that case so that you're guaranteed to always have a list for course IDs, or keys, even if they hadn't been added yet. Okay, that wraps up a description of the solution for this problem. What are the take-homes for this? Well, the key here is the idea of a map. Maps have keys and values, and the keys and values can be anything. For example, here we made it a string and an array list, but it could have also been a number, an integer, and a person, where you had let's say, a social security number associated with an actual person object. So the value can be anything from a single object to a list. And the keys can be any kind of Java type as well. The beauty of these hash maps is that once you set them up, you can then associate an object, your value, with a key. And this can be really, really helpful because you can retrieve that value very quickly based on a key. For example, in this assignment, the key was the course ID, and by using that course ID, you can immediately get a list containing a whole bunch of students that are associated with that course. Hash maps are very powerful programming constructs, or collections, a kind of collection, and one that you will find to be useful in a lot of programs you write, not only in this class, but in data structures, and really for the rest of your career, if you choose so, to be a software developer. Cheers.